Hello, today's topic is balancing chemical equations. First off, let's just see the law of conservation of mass. The law states that the number of each atom on the reactant side must equal the number of each atom on the product side of the equation. In this example, you can see that the number of atoms on the left hand side is equal to the number of atoms on the right hand side, which is the product side. Now, how do we balance the equations? There are some key rules for balancing the equations. First, to balance the equations, we add the coefficients in the chemicals. The subscripts do not change. It is very important that we don't change the subscripts. In this example, you can see that you add coefficients to every atom on the left hand side or right hand side, but you don't change the subscripts. General rules for balancing chemical equations. First, make sure chemicals are written correctly. That's the most important step of balancing chemical equations. Second, first balance the largest atoms on either side of the equation and leave out hydrogen and oxygen for later. Do not separate the polyatomic ions. Afterwards, balance hydrogen and oxygen atoms, combined or uncombined. So it is very important that we follow these steps in order to have a complete balanced equations. Yeah, the last step, check your answer by counting each atom. That's the most important step of balancing chemical. In this example, hydrogen peroxide reacts in presence of catalyst to form water and oxygen. So we begin with by writing the name of chemicals. Hydrogen peroxide H2O2 in aqueous state reacts in presence of catalyst to form water, H2O in liquid state, and oxygen gas in gaseous state. Notice that this reaction is a decomposition reaction. To begin with, we start off by drawing a T-chart. So yeah, on the left hand side, hydrogen has 2 atoms, oxygen has 2 atoms, whereas on the right hand side, hydrogen has 2 atoms, whereas oxygen has 3 atoms. So we need to balance the oxygen atom. So when we do that, we get this. Notice that we can change the coefficients on either side, but we can't change the subscript. Before writing the final statement, it's a good practice to check the answer. So we check it. Yes, hydrogen has 4, oxygen has 4. On the right hand side, hydrogen has 4 atoms and oxygen has 4 atoms, so it's balanced. Example 2. Zinc reacts with silver nitrate to form zinc nitrate and silver. So yeah, we follow the same procedure by writing the name of the elements and chemicals. So there it is. Notice that this is a single displacement reaction. So we start off by drawing a T-chart. On the left hand side, zinc has 1, silver has 1, and nitrate has 1 atom, whereas on the right hand side, zinc has 1, silver has 1, nitrate has 2 atoms. So we need to balance nitrate atom. So when we do that, we get this. So again, we end off by checking our answer. So yes, zinc has 1, silver has 2, and nitrate has 6 atoms on the left hand side. So same follows on the right hand side, where zinc has 1, silver has 2, and nitrate has 6. So it is a balanced reaction. Example 3. Solid iron reacts with oxygen to produce iron 3 oxide. So we follow the same procedure, first by writing the name of the elements, chemicals. Notice that this is a synthesis reaction. Yes, we start off by drawing a T-chart for the reactants and products. On the reactant side, iron has 1 and oxygen has 2 atoms, where on the product side, iron has 2 and oxygen has 3 atoms. So we balanced it, we get this. Yes. So in order to have a correct balanced equation, it's a good practice to check the answer. So we draw a T-chart again. So yes, so Iron and oxygen have the same number of atoms on the left hand side and same number of atoms on the right hand side, so it is balanced.